In this video, we will learn how to use the 5 climate controls to interpret locations around the world for their temperature impacts. There are 5 main climate controls: latitude, altitude, land-water contrast, ocean currents, and wind patterns. In order to understand these controls, we will look at each individually and apply it to the maps of average temperatures for January and July. Before we begin, we need to cover some terms to understand what we are looking at. The first is isotherm, which is a line on a map which connects points of equal temperature. Throughout each of these maps, we will find these. Another term we will use frequently is contrast, which is a state of being strikingly different from something else. In terms of this discussion, it'll be when comparing locations to one another with reference to temperature. With these concepts in our back pocket, let's start discussing these controls. The first control we will look at is latitude. Latitude impacts temperature as the further north or south one travels in the world, the less solar radiation, otherwise known as insolation, the area will receive. The reason for this is because the sun is generally centered over the equator and can travel as far as 23.5 degrees north or 23.5 degrees south, which causes the region to receive the vertical rays of the sun, while areas further north receive oblique rays. The more oblique the rays of the sun, the cooler the area will be in terms of temperature, as the insolation is spread out more. Using this with our map of January, we can see that the isotherms in the extreme north and south of the map are cooler when contrasted to those near the middle of the map. The same can be said when looking at the map of July. What can be inferred from this climate control is that the further north or south you are, the colder the temperatures, while the closer you are on the equator, the warmer the temperatures, both of which are a result of the amount of insolation the area receives. The second control is altitude. Altitude impacts temperature because the further up you are in the atmosphere, the colder the temperatures are. On average, the temperature of the air decreases by around 3 degrees Fahrenheit for every 1,000 feet of elevation change. The sun does not warm the air, but instead the Earth actually absorbs the insolation and then warms the air in return. So, as one travels higher in the atmosphere, the colder temperatures will actually become. On the maps of January and July, this is harder to identify as altitude is not represented on the map. However, knowing locations where altitude is higher, such as Mount Everest, we can contrast this location with other locations nearby and see, generally speaking, that Mount Everest is colder. The third control is the land-water contrast. Generally speaking, land heats and cools much faster than what water can. What this results in is temperatures in the interior continents being colder than water locations in January. The same thing can be said with reference to July, as temperatures in the interior of continents are warmer than water locations. However, another item that comes into play with land-water contrast are the impact on coastal location. Water regulates temperature along the coast, as the temperature of the water will help lower and raise temperature when compared to locations nearby. In January, you can see that the temperatures off the coast of South America are generally warmer than those near the interior, as seen by the shift in the isotherms. This is also witnessed in July, where coastal locations have cooler temperatures in July than those near the interior. The fourth control is ocean currents. Ocean currents control temperature because throughout the world there are cold and warm currents flowing along the coast of each continent. The temperature of the ocean current, whether cold or warm, impacts the temperature of the coast by causing the temperatures to be higher or lower than locations nearby. A warm current running up the coast of a continent will result in warmer temperatures along the coast, while a cold current will result in cooler temperatures along the coast. Regardless of the time of year these factors apply, as can be seen by the colder temperatures found along the west coast of the United States and the warmer temperatures found along the east coast of the United States. The final control is wind patterns. Wind patterns control temperature by allowing the temperature of a different region to impact the temperatures of another. For example, Canada tends to have lower temperatures due to latitude. During January, the jet stream typically curves from the Alaska area down towards the central United States. The outcome of this is cold Canadian air being pushed into the central United States, resulting in colder temperatures for the region, as is seen in the January temperature map. The same can be said with respect to July, as the primary wind direction in the mid-latitudes is from the west, which means the warm temperatures from the southwest United States cause warmer temperatures in the center of the United States. In summary, in this video we have learned how to interpret the 5 climate controls to analyze the temperature maps for January and July. The key items to remember from this discussion were how each of the controls had a different impact in different regions of the world. Knowing where each control impacts is crucial in properly analyzing temperature patterns for a region. Please feel free to share your comments and questions with your instructor regarding the content of this video, as well as to receive further guidance on the concepts covered.